Hi everybody, today we're going to talk about equivalent ratios. We already know that ratios can be written two ways. They can be written in colon form, like A colon B, or they can be written as a fraction, like A over B. We also know that we can reduce ratios. This means when we look at ratios, we can look for a common factor in both terms and then divide each term by that common factor. As an example, I have a ratio of 3 to 15. Both 3 and 15 are divisible by 3. So I can write my ratio as 3 divided by 3 to 15 divided by 3. We can simplify that as 1 to 5. Let's rewrite 32 to 56 in reduced form. We want to start by looking for a number that we can divide into both 32 and 56. You might want to start with 2, but I'm going to start with 4. I'm going to form the fractions 32 over 4 and 56 over 4. This reduces to 8 over 14. When I look at 8 to 14, I notice that I can divide some more. Because 8 and 14 are both even, I'm going to divide by 2. 8 over 2 and 14 over 2 reduces to 4 to 7. So my reduced ratio of 32 to 56 can be written as 4 to 7. I also want to point out that we could write this as a fraction, 32 over 56, which would reduce down to 4 over 7. As you're working on ratios, I want you to remember that every ratio can be expressed in multiple ways. Let's look at this problem that says select all ratios equivalent to 5 to 8. Before we do any calculations, which two choices could we immediately throw out? Take a look at your choices, 40 to 64, 30 to 48, 5 to 56, 35 to 56, and 48 to 5, and see if any two stand out to you. Hopefully you noticed the third one, 5 to 56, is not going to be an equivalent ratio. The first number is still 5, but the second number changed, which means those two can't be equivalent, so I can mark that one out. You should also notice that 5 is smaller than 8, and when I look at the last choice, 48 to 5, the first number is larger. That also tells me I can rule this one out. Now I'm down to 3 choices. I need to decide if the remaining ratios are equivalent to 5 to 8. So one step we can do is just to reduce the ratios and see if they're equal. 40 and 64 are both divisible by 8, so I'm going to divide 40 by 8 and 64 by 8. This gives me 5 to 8, which tells me these two are equal. Let's do that again with 30 to 48. 30 and 48 are both divisible by 6. When I divide 30 by 6, I get 5. When I divide 48 by 6, I get 8. So once again, I have an equivalent ratio. 35 and 56 have a common factor of 7. I'll find 35 over 7 and compare it to 56 divided by 7. This gives me a ratio of 5 to 8. This tells me 40 to 64, 30 to 48, and 35 to 56 are all equivalent to our original ratio of 5 to 8. Let's look at some examples of how we could use ratios in the real world. A water park wants to make a large fountain in the shape of a fire hydrant. They find the original size of a fire hydrant is 30 inches tall and 14 inches in width. If they make a fire hydrant 65 inches tall and 35 inches in width, do they have the same ratio? To start, we're going to take these numbers and write them as fractions. I'll write 30 over 14 and 65 over 35. We can separately put each of these numbers into our calculator and get a decimal representation. 30 over 14 is equal to about 2.14. 65 over 35 is equal to about 1.86. We can see that these two numbers are not equal to each other, which means these ratios are not equivalent. So let's see what we can do to fix this. We're going to keep our original ratio of 30 to 14, and we're going to figure out what height we would need to use a width of 35. The strategy I'm going to use to solve this is going to be cross multiplication. I'm going to multiply 30 times 35, and that's going to be equal to 14 times our missing number. We can simplify 30 times 35 to get 1050. Then to find our missing value, I'm going to divide both sides by 14. 1050 divided by 14 gives us a value of 75, which is the equivalent height we would need if we're going to do a width of 35 inches. Our next problem says, a restaurant staffs based on the expected number of diners. If their goal is to have one server for every 8 diners, how many servers are needed for 120 diners? Once again, we need to start by forming our ratio. We want to have one server for every 8 diners, so we need to figure out how many servers are needed for 120 diners. We're again going to use cross multiplication to solve for our missing value. We're going to multiply 1 times 120, and that'll be equal to 8 times our missing number. 1 times 120 is 120. To find my missing value, I'm just going to divide 120 by 8. 120 divided by 8 gives me 15, which tells me I need 15 servers to have the correct number of servers to diners in the restaurant.